Very good evening, my name is Jonathan O'Keefe. Today, we are going to be discussing about our project, the introduction to our project, which is called the Yara Projects, the Yara Parks. And the Yara Park, inclusive of all the site project, is located in Bandar Puteri Housing, Bandar Puteri Jaya, and developed for OSK properties. Now, the development the scale of this development details about a total of 237 double-story terrace houses units divided into three distinct types. Type 1 that has 122 units of plots of maybe 975 to about 1031 to 1044 and 1109. Type 2A plots of 1032 to 1043 and 1110 to 1203. In type 2B, we have about only 10 units, which is from plots 1204 to 1213. And the infrastructure for this plan includes that of detailed electrical infrastructure, electrical substation, new tarred roads, and concrete drainage planning, and fire hydrant placements.
Well, good morning. My name is Jonathan O'Keefe. Today we'll be talking about our mini project and what we will be doing today. So what we'll be doing today is taking off list. As you can see, this is our taking off list. To be clear, this taking off list, it acts as a systematic measurement process to bridge the gap between technical drawings and financial planning. The net measurement rule is that it ensures items are measured based on their exact physical footprint, such as 600 mm apron width, without incorrectly adding for mesh overlaps. And the cost mechanism, it enables the application of precise rates such as the RM10 ringgit 49 RM10 ringgit 50 cent per meter square to manage the overall project costs effectively. So in other words, this is basically the start for our project. Whenever we start a project, we start with the mini project for the taking off list.
Assalamualaikum, my name is Ahmad Naki Izram bin Ahmad Maizi. My Demetric is 241334010. Today I would like to talk about the general clearance. This section of the reports covers the general clearance and initial site preparation for the project as referenced in drawing PR2/DST-T1/FP/01. The scope of work involved clearing the site all bushes, scrubs and vegetation, including the grubbing for the roof. Additional, it includes the excavation of topsoil to an average depth of 450 mm, with the excavated material being removed to temporary spoils heaps for future use or disposal. Next is measurement methodology and unit of measure. The quantity for this element is measured in square meters, focusing on the total surface area required for clearance. The calculation follows a standard area-based approach, length, time, width, to determine the horizontal extent of the site preparation. This ensures that the entire footprint of the construction area is properly treated and stripped of organic material before structural excavation begins. Next, we talk about the excavation for trenches, rough foundation and ground floor slab. Introduction and project scope. This report details the quantity take off for excavation works, specifically for trench associated with the rough foundation and ground floor slab. The works follow the specification outlined in drawing number PR2/DST-T1/FP/01 and is officially documented under slipshod number 6. The primary objective of the excavation is to prepare the trenches for H-beams and thickened section of the rough foundation to ensure the structure integrity. Next is calculation methodology for excavation depth. To determine the precise volume of soil to be removed, a uniform excavation depth was established by combining two structural components. By adding the ground floor slab thickness of 0.150 meter to the rough foundation thickness of 0.225 meter, a total excavation depth of 0.375 meter was derived. This constant value is applied to all measured surface areas to maintain the consistency across the site calculation. The last one is about the excavation for pits, stump and pad footing. The introduction and project scope. This phase of excavation focus on the preparation for the pits, specifically for the stump and pad footing requirements as per drawing number PR2/DST-T1/FP/01. The scope involve the excavation for thickened H-beam and trenches required for the rough foundation. This process is essential to create the necessary structure recesses that will house the main support footing of the building, ensure a stable transition between the ground and the primary structure. Next is measure and area breakdown for slab and apron. The total area for this excavation is derived for two main components: the primary building footprint and its perimeter protection. The ground slab account for the largest portion, measuring 10.72 meter by 6.709 meter to give a total area 71.92 meter square. To complement this, an apron slab with a width of 0.6 meter is added around the perimeter, contributing an additional 10.1 meter square. Combining these two elements and ensure that both the internal structure and the external drainage protection are fully accounted for in the excavation plan.
Assalamualaikum and good evening. My name is Ahmad Reza Hakim Sabari. Nama Matric 241553739, and I will be explaining about the formwork. So first thing I will explain what is the formwork. Formwork is a temporary or permanent mold used in construction to hold fresh liquid concrete in its intense shape and position until it cure, harden and gain enough strength to support its own weight. It serves critical function, shaping the concrete into structural element like walls, column, beam or slab, supporting the immense load of the wet concrete along with the construction workers and equipment, and dictating the surface finish based on the texture of the mold material, depending on the project scale and budget. Formwork can be built on site using flexible timber and plywood assembled from highly durable reusable engineered steel or aluminium panel system, or left in place permanently as stay-in-place mold that double as insulation. So I will go to introduction and project scope. This report details the quantity take-off for formwork, especially for the rough foundation and ground floor slab of the corner tile house. The work follows the specification outlined in drawing number DTH/T1/1/8 and is officially documented on page number 13. The primary objective of this formwork is to contain support and shape the concrete for the H-beam, the thicker section of the rough foundation, ensuring the precise structural dimension and integrity during pouring and curing. The formwork quantity takeoff for the corner type 1 house based on the drawing number DTH/T1/1/8 is systematically divided into two main categories across slip number 9 and 10 to account for different structural element and specification. Under slip number 9, the general formwork for the rough foundation encompasses a total measure area of 24.229 meters square and we round up to 25 meters square. This total is split out from the perimeter and edge measurement of the foundation slab. It begins with the main rough foundation, each contributing 4.4 meters square, followed by the vertical formwork size along grids A to F, which account for 10,800 meters square. Because it is double to cover opposite the external wall, the horizontal boundaries along grids 1 to 6 at another 3.4 meters square to complete the foundation edge perimeter. The measurement incorporates specific structural extension. The section from grid 1 to 3A at 2.3 meters square, grids 1 to 5 at 2.7 meters square, and a final small segment between grid B and C at 0.629 meters square. Under slip number 10, the takeoff account for some formwork falling within the specific deck classification of exceeding 100 mm but not exceeding 150 mm, yielding a total measure of 4.266 meters square and round up to 5 meters square. This section insulate narrower vertical faces and it is split into distinct parts. First, the edge of the concrete apron contribute a minor 0.072 meters square, calculate using its 0.6 meter width and 0.125 meter thickness. Second, the ground beam specifically designed as GB9, GB15 and GB16 make up the vast majority of this slip at 4.194 meters square. This ground beam formwork is calculated by taking the total beam length of 3.495 meter and multiplying it by total depth 0.6, which account for both and vertical sides that need to be shuttered during the concrete pour.
Now we go on to the measure items, which is the reinforcement. So my part for this reinforcement is that we focus on high tensile steel bar reinforcement, which is our main reinforcement for our buildings, used primarily for stumps, ground beams and rough foundation. And the calculation for this is like the cutter length taken by the total length of the element, deduct the concrete cover, and typically 0.04 meters per side, so 0.08 meters total, times, and we had to add the two bends times with 5.5D, and the laps maybe about 40 diameter. Deep is diameter. Okay, then the final length is then multiplied by unit weight factors such as 0.888 kg per meter for T12 parts. And also we use the same method for mild steel, which is mostly used for stirrups and linkages.
Assalamualaikum and good evening. My name is Ahmad Rizal Hakim Sabari, number metric 241553739, and I will be explaining about the formwork. So first thing I will explain what is the formwork. Formwork is a temporary or permanent mold used in construction to hold fresh liquid concrete in its intense shape and position until it cure, harden and gain enough strength to support its own weight. It serves three critical functions: shaping the concrete into structural element like walls, column, beam or slab, supporting the immense load of the wet concrete along with the construction workers and equipment, and dictating the surface finish based on the texture of the mold material, depending on the project scale and budget. Formwork can be built on site using flexible timber and plywood assembled from highly durable engineered steel or aluminium panel system, or left in place permanently as stay-in-place mode that double as insulation. So I will go to introduction and project scope. This report details the quantity takeoff for formwork, especially for the rough foundation and ground floor slab of the corner tile house. The work follows the specification outlined in drawing number DTH/T1/1/8 and is officially documented on page number 13. The primary objective of this formwork is to contain support and shape of concrete for the H-beam, the thicker section of the rough foundation, ensuring the precise structural dimension and integrity during pouring and curing. The formwork quantity takeoff for the corner tile 1 house based on the drawing number DTH/T1/1/8 is systematically divided into two main categories across slip number 9 and 10 to account for different structural element and specification. Under slip number 9, the general formwork for the rough foundation encompasses a total measure area of 24.229 meters square and we round up to 25 meters square. This total is built up from the perimeter and edge measurement of the foundation slab. It begins with the main rough foundation, edge contributing 4.4 meters square, followed by the vertical formwork size along grids A to F, which account for 10,800 meters square. Because it is double to cover opposite external wall, the horizontal boundaries along grids 1 to 6 at another 3.4 meters square complete the foundation edge perimeter. The measurement incorporates specific structural extension. The section from grid 1 to 3A at 2.3 meters square, grids 1 to 5 at 2.7 meters square, and a final small segment between grid B and C at 0.629 meters square. Under slip number 10, the takeoff account for some formwork falling within the specific depth classification of exceeding 100 mm but not exceeding 150 mm, yielding a total measure of 4.266 meters square and round up to 5 meters square. This section insulate narrower vertical faces and it is split into distinct parts. First, the edge of the concrete apron contribute a minor 0.072 meters square, calculate using its 0.6 meter width and 0.125 meter thickness. Second, the ground beam specifically designed as GB9, GB15 and GB16 make up the vast majority of this slip at 4.194 meters square. This ground beam formwork is calculated by taking the total beam length of 3.495 meter and multiplying it by total depth 0.6, which account for both and vertical sides that need to be shuttered during the concrete pour.
Assalamualaikum, my name is Nur Emilia Nurhani. My matrix number is 241332228. In our group comprehensive project analysis for Yara Park, we have worked through the initial measurement schedule and the systematic build-up of the bill of quantities. My core responsibility in this presentation is to dive into the commercial engineering phase, specifically the first principle build-up rate analysis for our primary structure element. I will detail how we translate whole soft data into our final competitive or intended rate for terrace type 1, 2A and 2B. To establish a 2D level analytical baseline, our rate in this study is broken down into the three raw cost components: material exclusive of wastage, detailable constant, and mechanical plant operation costs. Subsequently, compound with a standard 50% overhead and profit. Let us begin with our vibrate reinforced concrete grade 24 engineer for the terrace structure unit. In the base, ready-mix concrete material sit at 282 ringgit per cubic meter. We have applied a strict 5% academic wastage factor, accounting for one side spillage and geometric variance, alongside a logistical subcharge. Oh my God. The labour cost account for 1 hour of skilled worker placement and 2 hours of general worker labour, combined with the mechanical rental of structure focal vibrator at 32 ringgit and 36 cents per hour for half an hour. Our total prime cost is 352 ringgit and 93 cents, compounding this with our 15% corporate make our final strategic unit rate is 405 ringgit and 87 cents per cubic meter. Okay, moving over the steel reinforced element, our project model analyzes both high tensile bar and my steel reinforced per kilogram. In the market context of this project, both steel configuration share a identical commercial base cost of 3 ringgit and 10 cents per kilogram, paired with standard 50% cutting and bending of cut wastage value. For a level productivity standpoint, our analysis utilized a skill level constant of 0.012 hours per kilogram for fixing and 0.010 hours for general handling. Now, if we convert this number mathematically into time, 0.012 hours translates roughly 43 seconds per kilogram, while 0.010 hours is exactly 36 seconds per kilogram. On paper, 43 seconds sound impossible for fast to cut, bend and fix a rebar. However, as a critical analysis, this reflects productivity at the construction site. Workers do not process rebar one by one. They utilize mechanical bar cutter and bender to process dozens of heavy steel bars simultaneously. Because steel is inherently heavy and processed in massive volume, the calculation is highly realistic, returning a total prime cost of the average time consumed per kilogram dropped significantly to under a minute. Therefore, this calculation in highly realistic return a total prime cost of 3 ringgit 60 cents and a finalized unit rate of 4 ringgit 14 cents per kilogram. Next, we look at the structure floor slab component, specifically the BRC steel fabric reinforced ranging from A6 up to A10 specification. As a quantity surveyor at this level, it's better to track how the escalated structure weight directly drive the material pricing up, while labor placement speed remain uniform. Across all four profiles, the labor cost stay fixed at 1 ringgit and 1 cent per square meter because the physical area development proceeds remain identical regardless of wire density. However, the material density drives the final price. For match A6, the baseline material is RM7.45, giving an all-in rate of RM10.50 per square meter. Stepping up to mesh A7, the all-in rate is RM30.27 per square meter. For A8, it worked out to an all-in rate RM16.45 per square meter. And finally, our density specification, mesh A10 carry a base material cost of RM80.50, generating a compound with unit rate of RM24.24 per square meter. Our fabric rates successfully account for a 50% spillage factor. Our final structure element is formwork. Formwork construction inherently a labor-dominant task, and our analysis highlight a very important trend. While the base material cost for the timber framing and boarding is calculated at RM30.33 per square meter, look closely at the labor matrix. Its demand heavy carpentry installation consist of 0.80 hours of skilled trade work, coupled with 1.03 hours of general labor for striking, oiling and clearing. If we convert this, it takes a carpenter about 48 minutes to set up, and general worker about 1 hour and 2 minutes to strike and clear a 1 square meter of formwork. This drive our subtotal labor cost up to RM23.59, making labor to single largest cost driving in the rate build-up, accounting for more than 50% of the prime cost. With our 50% overhead and profit levy applied, the final commercial rate is set at RM44.37 per square meter. To conclude, this unit rate pull-up analysis show how crucial is to look at the microscopic detail in construction economy. We have just estimate price. We have systematically mapped material, labor and equipment rate specifically for the Yara Park project context. This ensures our group final bill of quality stand up to rigorous academic and real-world evaluation. Thank you very much for your time.
Truly told, this is our BQ, and our BQ actually consists of a detailed document for construction procurement that lists the total quantities of materials, labors and parts required for our project. And truthfully, our project is actually came with a BQ prepared by the construction company. Usually the state goes that our project has to come up with build-up rates to create this build-up quantities. We learn how to create our build-up rates based on the quantities that is given in the build-up quantities. We learn how to deconstruct every single labor, every single material wastage based on the rates given in the build-up quantities. This build-up quantities that is given about 400 or so pages is now reduced down to maybe about 2 or 3 pages just to show you what exactly it's all about, especially based on our work below 4 finish levels.